So when trying to find where systems of equations intersect, there's actually given two variables and two equations, there's three possible scenarios that can come out. The first being that they actually do indeed intersect. So we get something like this. They intersect at one point. This is called a consistent system. And since the two equations are the same equation, or different equations, they're called independent. Now, another thing that can happen is that we still get a solution, but they're actually the exact same line. They fall right on top of each other. In this case, they are also consistent because we did get a solution, but they're dependent because they are indeed the same line. A third case, which happens sometimes, is that we don't get a solution because two things are parallel, meaning they'll never cross. In this case, they are inconsistent because they never cross, but they are also independent because they are two separate lines. They're independent of each other. So when solving systems of equations, ways to know which system you've hit, in this case, you'll end up with some type of XY pair. You'll get a solution. In this case, when you solve either using substitution or elimination, you can check out other videos to see what those are about, you're going to end up with some type of true statement. For example, 0 equals 0. Since it's true, but there's no variable left to solve for, they're the same line. Another way to tell this type has happened is, for example, say I was given this equation. If the other equation is just a multiple of it, so say I times everything by 2, and these are the two equations I was looking at, when they're multiples of each other, they'll also end up at this case. Parallel, well, we know how to spot parallel lines now. This case happens, so if we go to actually solve, we're going to end up with some type of untrue statement. For example, 0 equals 5, which we know is not true, but there's no variables left to solve for. And so this happens to be parallel lines. Another thing to note is they'll have the same slope if they're in y-intercept form. Then we know they'll never cross, and you're left with an inconsistent independent system.